Hi everyone. Although I posted already um, the lecture notes, um, but I think the hands-on lab or my the practice on the real database may help you understand better. So I am recording my lecture again. The topic that I'm going to share today is transaction management. The transaction is a one single atomic unit, which consists of a sequence of database operations. Okay, so you can include the DML and DDL of SQL in certain order. So as a whole, that will be one transaction. If it is a one transaction, then because it is a one unit, an atomic unit, what that means is that once it starts, it should finish complete. If there is any error in between while it was executed, then everything should be returned back to the condition before that transaction begins. Okay, so either there will be no effect of that transaction because of the abortion, or the completion. All right. Let's assume that this kind of the sequence of operation. So we start to begin. We have one update and another update followed, and then commit finally. Ironically, this guy is talking about the same table for the different ID, or could be same ID. If it is a different ID, then we can think of, for example, the customer 1 send $100 to customer 2. So $100 may be subtracted from the customer 1's balance, and then add it to the customer 2's balance. So that this type of the transactions may be very, very common in databases, because we need to confirm all the required actions to be taken completely. If there is any error inside, then we should abort them all, so that we need to make the database with nothing to be happened. Among the banking systems, this is very common. Airline ticketings, that is also very common. Hotel transactions, reservations, all kinds of reservations, so that is also very common, right? There are many similar situations available. So why transactions? Why we need to think of this? A transaction exists to make sure that when multiple changes happen in a database, they happen safely, consistently, and completely. So we have to ensure data integrity. So make sure if there is any changes, then that should be all completely changed. If any single ones, minor ones, not completed, then we need to abort everything. So we have to make nothing happen to the database. That way, database will be maintained consistently. And also, we have to protect the concurrency controls. If two different transactions works, and part of the operations in both of those two transactions are targeting the same database, the item, then that may cause some issues, right? That may violate some data integrity or consistency issues. So we have to make it very carefully. Concurrency control is also same. Although multiple different transactions, because it consists of operations, they are interleaved each other. So transactions are interleaving each other. That is allowed to enhance the performance. But at the same time, all the database effect should be done as if one transaction is performed at a time. One transaction at a time. Then there is no issue because there is no intervenes each other, no related one to another. Because after one transaction complete and the other transactions starts, if we have that patience, then that our database becomes okay. We keep our database for integrity and then consistency, right? But under the current significantly powerful computings in our database, it is not a good idea, right? Simultaneously, multiple different transactions needs to perform because we have multiple CPUs running, and also we have very good concepts of multi-threadings and virtualizations. All those the high-tech available. So transactions can be interleaved one to another. Very, very complicated fashion. Still, even so, still we have to make sure our database should be consistent and should keep its integrity as if one transactions performed at all time. So there is no affection each other. There's a concurrency controls, right? All right. So usually, in order to control the concurrency controls, if one data item is being handled by one transaction, then usually we use lock mechanism. So we need to lock that item. So at a certain point in time, the data item, if it is locked, then no other transactions can work on it because it is locked, because it is held by a particular transactions. Once it is done by that transaction, then lock will be released. So that data item will be unlocked. If it is unlocked, then another transaction come in and work on it. Okay, lock mechanism is one of the secure mechanism to control concurrencies. All right. So that's the concurrency control is something that we have to consider very carefully when the transactions beautiful idea comes in. So things becomes complicated. One beautiful idea comes in, then it may cause other the previously beautiful ideas the trouble. Therefore, we have to make sure everything should be nicely worked. If there's even if we are handling very carefully up to this, there may be some cases something happens, right? Then another mechanism that we have to think is, if there is a failure, then we have to recover it. There are, again, so many different kinds of recovery, the techniques available. All right? So usually what we do in the database, we put a checkpoint, not periodically in calendar time, but periodically depending upon the transaction context. So put the checkpoint, and when the checkpoint is on place, then all the actions taken already should be flashed. Flashed means should be saved into the disk. So the data should be persistent, should be permanent. So after that checkpoint, then everything can be handled in the memory. So that is volatile. It is not yet saved. Still something going on. And then if something complete, then we also place another checkpoint. And everything completed before that checkpoint should be saved for permanent storages. So if something happens, then usually they need to roll back to the previous checkpoint and make sure whether everything done at that checkpoint saved permanently, then go back to that point and we do everything undo. Everything, if not saved, since some checkpoint, everything should be undone. So we have to undo everything as if nothing happens. And we have to make sure everything is complete and persistent before certain checkpoint. So that is recoveries, right? Recovery is to make our database consistent and integrities at some point in time. So that's recovery can be done, right? And also handling of transactions is like a programming logics. Okay, so programming logic is applied to database transactions. Okay. Some of the motivations. $100 transferred from the customer ID 1 to customer ID 2. Okay, so customer 1 is 1111, customer 2, the ID is 1112. In between, something happens. Therefore, first operation is done, but second operation is not done. But everything is one transaction. Because the money transfer is one transaction, right? One unit. Other than that, there may be a lot of problem, right? So when I send the my money to, for example, payment, right? So payment extracted from my accounts, but not accepted by whoever needs to receive. Then there is the problem. So we need to put them in one transaction, and we handle it as a unit, atomic, which means we should not decompose, we should not split them like this, okay? Begin and end, everything should be in. So as a unit. If it is a unit, then effect should be complete or nothing. So as far as a transaction, we have ACID properties. Atomicity. A transaction should be atomic. Okay. Consistencies. A transaction moves the database from one valid transaction, one valid state to another valid state. If there's something happens, then we need to go back to the previous valid state. If it is complete, all satisfied, then move to the next valid state. That's consistency. Isolations. Each transaction executes as if it is alone. Although systematically they are interleaving each other, but the effect should be independent. Durability. Once a transaction is committed, change should be persistent. So that is called ACID properties. So hands on. A transaction should start with the begin and commit. Commit means it's all done safely. But we can unset the commit. By default, MySQL, by default, MySQL is to commit automatically, although we don't do, right? Even each single database operation, even we don't consider a transaction, but operation. For example, insert into table values, some of the values, done, hit enter. So it is, for example, one row is affected. But MySQL, if you don't do anything, by default, automatic commit. So it is affected. It is persistent. But some other databases, it is not automatic. You have to do commit, right? So this is default issues. Control commit in transaction. So in our transaction, transaction start with the begin, or we can say start a transaction. Both are okay. And with the commit. Somewhere in between we have a rollback, or we have a rollback to a particular save point. That save point that we marked, we say save point here, and then we can say save point 1. And later, at some point, we can say roll back to save point 1. Then it goes back to that point. If we say roll back only, then systematically it's completely roll back. So go back to the previous database states. MySQL version 9 or above, there's a transaction engine support to save points, roll back to save points, release save points. Okay, so we are okay, so we can enjoy this. Commit after successful operations. So start transactions, we do this and the commits. So all changes become permanent, persistent once the commit executes. If you omit commit, automatically roll back on the disconnected. But by default behavior of MySQL is automatic commit. There is a later points I'll show to you. Okay, here with set auto commit equals 0 equals 1. Okay, so equals 0 means it's not auto commit, and then we make auto commits back to 1. That is also possible. Roll back after an error. If we say this, sort, and then we can roll back. Save point, we set up save point right after insertion. And we updates. After that updates. And at some points, hey, something happens, so that we have a rollback. Roll back to save point. This is a particular the label that we marked. Current version of MySQL 9 serves both InnoDB storage engine. InnoDB storage engine works perfectly fine for this kind of rollback and save points. But if you are using MyISAM engine, then this is not going to work, right? So for us, because InnoDB by default is running, so we're okay without considering any extra. We're all set without having to do any other specific. Multi-save points also possible. Save point to 1 and save point to point A, point B, and at some point we can say, hey, I want to go back to point B. So this will be ignored, right? That is also possible. And then mixing DML and DDL. If you want to do this, then we have to do very carefully, right? Start a transaction and create a temporary table called temp customer from customer's database. If customer is still active, then we extract those customers into a separate table. We call that temporary table. Temporary table is basically temporary. So it is available while the same session is on. If that session is done, then temporary table will disappear. Session means, in this case, when you log in as a user, there is a one session. So when you log out, then temporary table will be gone. So create this and delete that once. if last login is 2025 October 15, then we want to delete it. This is so we have DDL here, right? Delete. Create, that is also DDL. Well, I think create, usually that is a DDL, and delete maybe TML. But anyway, roll back. Won't undo DDL in MySQL because it is auto commit already done. So don't expect you can do rollback when you use DDL. That's what it is. So what is a rollback? What is a rollback to save points? So rollback or rollback to save points. If it's a rollback, then undo all steps. So transaction start and so rollback, then everything within that transactions, all the operations within that transaction will be undone. Roll back to a specific save point. Therefore, we have save point here and save point here, and then roll back. Then only this will be, step 3 will be undone. So because of this is the issue, in order to fix it, you can make a procedural language in MySQL. So we have a delimiter, open and delimiter, and then create procedure we call the show active customer, begin create temporary table, same as that, and then we can do this. This will be okay. Conditional rollback also possible. So we make a procedure, so called that adjust the price. Within that, we have transactions. So we can say, if something happens, then we roll back. Other than that, commit. This is whole transactions, which is very nice, right? We call that conditional rollback. So when you update, here is the products. The price is increased by 10%. Let's say that is a VAT. I think this is a I think value added tax, right? Value added tax. Tax may be added when the products moves along the path a product moves, tax is imposed. There's a value added tax. From manufacturer to the customer, there's a long path to move. So somewhere, every step we can apply. For example, it was manufactured in somewhere outside the United States. And then there's a tax, import tax. And it goes to the wholesaler. So when wholesaler distributes the products to a retailer, they also charge. If VAT tax is applied, right? And then that retailer also charge the tax to the buyer, customer. So multiple steps of tax charges. Let's say that is applied. If the average price, some of the products, average price is over 1,500, then we roll back. Other than we commit. So depending upon the database, we have either in this case, if it is high priced products, then roll back. Well, you can change this, right? High priced item, then move. More VAT tax, or the other way, right? Roll back or commit. So, yeah, that is that. Yeah, this is real things. So this is a VAT tax. This is the procedure, right? We define the procedure, and then we can call that procedures. For example, we insert to the data, to the table, insert into products, say name and value only, 100, 300, and 700. Average is 366. If it is 366, then that is not over 500, therefore it's committed, right? Oh, wait a minute. Oh, it's less than 500, so that it roll back. If it is higher than that, then select before A, products. So from the table, we select, we get the average, and we call that average before. 2 columns. First column, we arbitrarily call that the notes. And the second column is the average. We call that average before. And we call adjust the price. So that is called. Okay? And then select again. So initially, we insert this and select, then it shows us as it was inserted. When we invoke this procedure, after this procedure, then there's a VAT tax is applied, so that we may have different. This is very, very interesting example. So we'll go back to this, okay? Auto commits, we can control the auto commits on and off, right? And also we can see auto commits, whether it is currently on or currently off. Any variable that's defined in my database can be seen, can be retrieved by this command. Show variable, like some of the wildcard. If the variable starts with auto, followed by anything, okay, so %sign here, auto %, then in many other programming language, this is like auto star. Other programming languages, but in database, we use a percent sign. Nested transaction also possible. Say here, save. This is not inner. I mean, it's not. We have one save point here and another save points. This is outer transaction save point, and other save points inside. This is possible too. And partial rollback. We could make commit doesn't interfere. So we say the auto commit is off. Make sure auto commit doesn't interfere. Okay. Save points after that transaction begin, and we update. So balance 100 out from this account. And then we make sure if it is subtracted. Select. And we put there another inner transaction and outer transaction, two different save points. And then we update the customer set. We add the $50 back to the same one. So the first step, we subtract 100. And in the second step, we add 50. And then we undo, roll back, say we roll back to this, which means this step needs to be undo, right? So partially, only this is undo. All others can be done. This is a partial rollback, right? Full rollback is everything rolled back. Everything here that is rolled back. If we say rollback, so somewhere I think I put, yeah. Concurrency control. Let's say we have two terminals, A and B. Terminal A runs transactions. So for the same table products, two different transactions takes place. We can simulate this by having two different terminals, A and B. So in session A, which is terminal A, we say products, we update the products, okay? We subtract the product stock. Session B, for the same products, we again, yeah, this is also subtract, right? For the same ID. And then A commit, but B is not yet. If it is not commit, if a commit is not auto. Default constraints workaround. MySQL does not support default constraints. Well, right, MySQL does not support this, but anyway, if we have a foreign key checks, what that means is that order is made before customer is, let's say I'm not registered customer, but I want to still place my order. But my database says in the order table, there is a foreign key, customer's ID should refers to the customer ID. So customer should be pre-existed. Therefore, order may be possible according to database design. But if a default constraint is available, which is not the case of MySQL, some other database engine could do, right? Then we can say foreign key checks 0. So foreign key is not checked. If it is not checked, then we can insert order first. We first order, and then we can register my customer's ID. Sometimes it may be possible, right? Like emergency in the hospital while you are traveling abroad, for example. You have an accident, so you are hospitalized. In that hospital, you are not, your name is not registered, right? But they first admit it, otherwise your problem will become bigger and bigger, right? So admit it first. That admit table, where there is a patient ID, then patient ID is a foreign key, therefore it should check whether patient table has already that patient in it. But the patient is not, right? And then default is really useful in that case. So first admitted it, and then later they can do that. All right, so this is the transaction. So transaction gives you a very, very interesting and sometimes a very significant the functionalities. And then later, in this case, default constraints. This is really, really significant. Without this, then cause a lot of trouble. So this is meaningful and useful and needed at some points in time. So let's try to do some. I'm not going to do all, but let's try to do some. Let's say, I think I need to first open. .525 dB, so I want to use 525 dB and show tables. I think I have already, yeah. So select star from customer, then I have customer ID, name John, Sam, Peter, balance, last login, and active. Last login here is not really auto login, but that is how I entered. Okay. So description of the customers. I didn't put any primary keys or foreign keys, only I created CID name, balance, active, that. You know, I want you to do this. This is the next homework assignments, okay? Exactly the ones. So I'm going to show to you tables more. There's a customer and department. No, we don't need a department. We need customer, orders, and products. Okay, 3 tables. So orders, because department, student, those are not for this hands-on. That is for something else that we already did, all right? So orders. By the way, when you do orders, order is not accepted if we have singular. I have all singular for table name, but the orders is not, because order is reserved word in database. For example, when you sort the order by, right? So that is a reserved word. Don't try to use order, singular, for your table name, while all others singular. Here, customer, product singular, and order, that is plural, right? So I have select star from orders, then I have those orders. And then products. So those are products. Remember that I have, right, the price is floating points, 4, 2. 4 means including this decimal points. So you can use only up to $99, not the triple 3 digits. If you want to make 3 digits, then you need to have a 5, 2. So I have TVs, this is a product ID, PC, washer, stock, and then company, and then price. Okay. So let's see where I can do a rollback. Others is very simple that you can practice, right? And I want to make another shell here. Basic. So I want to make it a little smaller, and this is a little bit adjust. Let's say I have here start transaction and product. If it is 555, I want to reduce the stock by 10. So products here. The ID PID 555, that PC. Stock is 199, so I want to sell 10 of those stock inventories. So I want to do this. So it is done. So when I do select products. It's not affected yet, right? Query OK, 1 affected, row matched 1, changed 1, warning 0. PC 199, but it is not, right, yet, because it is not commit. So if I do commit, then I think it is affected. So when I do this, it's 189, right? It is affected. So when I redo this, again, 10 more, still not affected. When I do rollback here, then still, because I rolled back already, it's not affected. Unlikely before I did a commit, therefore it dropped from 199 to 189. But when I do rollback, when I do commit, then it finally, persistently. But when I do rollback, I did rollback here, right? So it's not. When I do this, still 189, never affect. There's a rollback. And also there is a particular points, right? So, for example, I want to insert OID, and I want to change this to, for example, 7, okay, because I have already 1 and 7. So I inserted orders, OID 1007, status pending. I inserted it, and then I put save point, and then update that exact same ones. Or initially, if it is ordered, then it's still pending, and then little later we say shipped. That order is shipped. Okay, so I changed it, and I said it is shipped, but immediately the client canceled that order. Then I have to roll back to the previous order, right? And I should not say it's not shipped, but still pending. I need to go back to pending states rather than shipped states. I would say it is not because of the cancellation. I think because of internal problem, right? Maybe truck loaded, and then I thought I can ship these products to truck 1, but truck 1 already left. Then truck 2 comes in yet. Didn't come in yet. So it is not shipped, still pending. So I need to push back to the still pending situation, then I need to do this. Okay, so I want to do here start transactions up to insertion and updates, and then I want to see this is orders, right? So select star from orders. 1007 is not yet come in, right? Although we do insert, it is not, because didn't commit yet. And all of a sudden, if I say rollback to save point order created, I want to go back to that. If I commit here, then I think it'll be shipped, right? let's say I think this is a different session. This is a current session. Current session may orders. Yeah, current session can see it. It is shipped in the current session, right? But when I do rollback, and then you go back to pending. Here, shipped and go back to pending. When I say this guy did not see because this is different session. So let's see this here. Okay. So at this point, it is pending and shipped, but roll back to the save point, the previous save point. So it rolled back to pending. Why? Because MySQL automatic is an automatic commit. So up to this point, it's an automatic commit. However, MySQL also support rollback to save point, which is good, right? So it rolled back. Multiple save point, that is also possible, right? Say I want to show this. So let's work on the order. Another, this is separate ones, okay? Not, I want to insert separate insertion. Not with the PID, so it'll be null, I guess. So when I do select star from orders, then I have another null, right? This is what it's pending. And I said, I want to push it to delivered. Copy. Because it is delivered. So when I see this, then it says delivered. Still, I can roll back to this pending states. That's very similar to the other, right? And then when I do commit here, it'll be committed. Therefore, if it is a persistent, then outside it can see it, right? So that is delivered. Even different sessions can see it because data becomes persistent. Mixed, if we do this, then yeah, do not try to roll back because it is already deleted. Let's see. When I do this, I want to create a temporary table, okay? So copy. So temporary table. So let's see. There is no temp cost. I think I can see temporary tables. In what way that I can see temporary? There is some way that I can see the temporary tables. Wait a minute. let's see. Yeah, temporary customer table is still available, although it is not, right? It is just temporary, so it can be seen only in on these sessions. But we can see still on the same session the schema of that temporary table, which is the same schema as customer, right? Because it comes from customers. Same ones. So that is created. So if we see select star from then we can see those guys, right? Originally star from customer. Oh, we're still all the same. Here, where active one. Oh, because they are all active. Because they are all active, right? If we do, but anyway. And then if the last login is before October 15, October 20, only this is October 15, right? So I want to delete this by having this. So that is deleted. So when I do, then that is deleted. Original customer is still this, because I made the temporary, and from that temporary tables I want to delete. From that temporary tables I want to delete if the last login is earlier than the January 1st 2025. So that is deleted. And then if we say roll back, see if that is rolled back. Temporary customer, cannot be rolled back, right? Empty set, because it is rolled back, then everything gone. Because it rolled back, it's not particular points, but everything disappeared. So temporary tables disappeared because of this. To avoid this, you need to make a procedure. So I have a very good procedure here. So I want to create this procedure. Remember that the bad text. So that is defined. So adjust the price is defined. And then I want to enter this to that tables, 3 rows. Out of range of, let's say products. Oh, I have here 4 to 2, right? So this is a range 3 digits, but should be 2 digits. So I need to do separate. I need to change this here, right? Say $10, $30, 70. So average is a little issue, I guess. So copy. Should be okay. But I need to change this to 500. The average should not be 500, right? Because of that. So I want to change this to maybe 50 instead of 500. Greater than 50. I want to redefine this procedure. Okay, redefined. So everything is okay. Now I want to see, say, this SQL. So that I can see the currently those among those three that I entered, the average before the procedure invoked, the average price is 36. Okay, if it is less than 50, oh, I need to change this to 50. So a little bit, I want to redefine that. Okay. And then I want to call that procedure, call adjust, copy and paste. So that is invoked. And then I want to go back and see mine. Previously, the price was 36, but it was changed to 40 because right, I put $10, $30, $70, but there is a value added tax added. If it is greater than 50, then we need to reconsider. If it is less than 50, then we commit it. We select and commit it, right? We commit it here. And we can see also the variables. So show variable like, if there is auto commits %, then we can see auto show variable like auto. So whatever, show variable like auto. Is it singular? Have an error is going to check the manual for my syntax and here variable like auto. I think variables plural of variable. Show variable. Let's see if it is variables. Yeah, variables. It should be variables. Auto commit is on. But if you say set auto commit equals 0, then it'll be off. If we want to set it back, then you need to set it to 1, then it'll be on. Nested transactions. I'll move further. Yeah, default this is not allowed, right? Here, concurrency control. Yeah, 2 terminals. Let's try to do 2 terminals. So if we do on the products, update stock, so I can do here paste. So it is done. So when I do select from product, stock zeros or none. So I want to go back to the case of initially all PIDs. This is all gone. So when I want to bring it back. I think I have somewhere here. Okay, I want to have it here. Products. Okay, after that, I will do this. So if PID is 555, I want to update. I want to reduce stock by 1. Okay. So I want to show to you what I have. Products. I have 555. Stock 200. But I want to reduce the stock so that my products goes down by 1, right? From 200 to 199. From here, this session. So I want to do the same one here. Here, I want to see stock that. Because this is not commit yet. On another session, I cannot see it. So here I want to also reduce. Paste. What happened? So I did this. Select and update. Do not come in yet. Okay, so do not come in yet. But I need to I want to go back. So when I see this, still 199. This guy think 199. Oh, this guy also think this is not yet. I don't want to start here. I think because this guy tried to update already, so there is a lock. So when I do this, paste, because this guy is not commit yet, so this guy is still waiting until this is a commit. That is a concurrency control. So when I do here, commit, when I do this commit, watch this, when I do commit here, then after commit, log is unlocked, therefore this session will continue. This guy is waiting until the log is released. So when I commit, then this will proceed. So when I do this, see that's proceeded, right? So this guy can see, select from product, then you can see 199, right? His own committed, and this guy finally committed, and this guy also can see 198. Oh, this is 199. Just commit. If I do commit here, then I think he can see that. Commit. Let's see. So that he can see commit 198. All right. I think this is the hands-on. So exact same ones I want you to practice, and I will describe what you need to do for your homework assignments a little later, because you need to practice this. This is it may a little over time. I think I want you to work on this next week. All right. Thank you. See you.